Greetings. This is Unit 1, Module 2, Session 2. The name of this home connection is Factors and T-Lights. It's a two-pager. Please write your name and number at the top. So speaking of T-Lights, it looks like in number 1 we're going to imagine using 48 tiles to build each of the rectangles below. So no matter how we arrange the T-Lights, there's going to be 48 of them arranged in some sort of rectangular shape. We want to write in the missing dimensions on the rectangle sketches. I'm going to start by zooming into this first one. I can't zoom in too much more because of how wide it is, but it looks like you are going to consider the number 1, which is maybe it's 1 T-light tall, and you have to figure out how many T-lights across. We know that if we multiply the height and the width, that we will figure out what the area is, or the number of T-lights inside. So the question we're going to ask is 1 times what, this number that's missing right here, equals the 48 T-lights. So all of these rectangles, whether it's our long skinny one or maybe our one that's closer to a square, it's going to be multiplying the dimensions to figure out the area. And one of them is going to be missing. Okay? So 1 times what is 48? Well, 1 times any number is the number, right? So we should probably say that this is a 48. If we look at the one right below it, I can get a little closer. 2 tall, not sure how many wide. So once again, we set up that as 2 times what is 48. Still trying to get a 48 in the middle. Well, what number can you double to get 48? Or you could think of it as in, if I cut 48 in half, what is remaining? Well, half of 48 is 24. And you could flip that question around and you could say 48 divided by the number that we do know is the missing number. Okay, so if I wanted to divide 48 into 2 equal pieces, it would be 24. That's what I would write in the box. Setting it up again is that if I take this 8 and I multiply it by something, it should still equal a 48. So we have to figure out what that missing number is. 8 times what is 48? And you could think of a ratio table. 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. 4 times 8 is 32. 5 times 8 is 40. 6 times 8 is 48. Oh, there's my answer right there. 6 times 8 is 48. And maybe you know the fun rhyme that goes with it. Maybe not so much fun is when you see lots of double digits, but I'm going to tell you that I'm not too worried about this. We can be very methodical. We can say 16 times what equals 48. And if this is something that you think is really challenging to do mentally, well, don't do it mentally. Let's just take a 16 and add another 16 to it. What do we get? Well, 6 plus 6 is 12, carry the 1. And if I add those 3 ones together, I get a 32. So I know that 2 16s is not enough. So let's go ahead and add another one. So we'll take this 32 right here. We'll add another 16 to it. 6 plus 2 is 8. 3 plus 1 is 4. Oh, there it is right there. So how many 16s was that? Looks like there was 1, 2, 3 of them that I added together to get 48. So 16 times 3 is 48. And it is okay when you get into those bigger numbers to maybe methodically add them together. There are other ways we could think of it too, but that might be a solution for you. And then this last one, setting it up the same way, 4 times this number is 48. Wait. This looks very familiar. I've seen a 48, and I think I've seen a 4. Am I right? Have I seen a 4 on here so far? Ah, no, I wasn't. I thought I was going to see a cool pattern, but not so. Maybe I could teach you a little trick with fours. Um, but if you're looking at this and you're thinking, oh, math facts, 4 times something is 48. Well, go through your math facts that you might think. You might start with fives and you might say, well, 4 times 5 is 20. Well, that's not big enough. 4 times 6 is 24. Well, that's not big enough. In fact, 24 is half of 48. So I might actually have to double this number to get the answer. Otherwise, you're going to spend a lot of time going 4 times 7 is 28, and you're going to just keep going, going, going. It might take you a while. But if you know that 24 is half of 48, well, let's double this 6 and we would have 12. And if you were not confident that that is the answer, you could double check by taking 4 12s and adding them together. 2, 4, 6, 8. So this is an 8 down here. 1, 2, 3, 4 right here. Ooh, and we are correct. That is 48. Now it's going to specifically talk about the factors of 48. That means the two numbers that you can multiply to get 48. And in several cases, like the number 48, there's more than one way to make the number 48. And so I kind of have to back out here for a second. So I can do 1 times 48. I can do 2 times 24, 4 times 12, 8 times 6, 3 times 16. No matter what, multiplying all of those pairs gives you the same answer, which is why it says 48 inside each rectangle, because that's what happens when you multiply those pairs. So let's put them in. So 1 and 48, 1 and, what are we missing? The 48. Let's find the one with a 2 in it. 2 and 24. So we should put a 24 in here. 4 and something. Where's the 4? Where's the 4? Where's the... There we go. 4 and 12. And then let's find 8 and whatever's missing. Which one has an 8? There's the 8 and 6. And then finally 16 and something. 16 and 3. So those are going to be our factor pairs. All of the pairs that can be multiplied to make 48. Question 3 says, is 48 a prime number or a composite number? A prime number, if you remember, so let's see, I could say prime, only one factor pair. Okay, that's our definition, right? So a prime number would be like 1 times the number. That's the only way you can do it. So it would be like 1 times 3 is the only way you can make 3. Technically, you could say 3 times 1, but aren't those the same numbers? Yeah. So if you ever in a situation where you can only make the number by taking it times 1, we know that's a prime number. Okay? Which means that a composite number is going to be where you have more than one. Oops, I didn't mean to write that. So if we're looking at the number 48, which is represented by all of these rectangles here, yeah, there's a 1 times 48, but there's also 2 and 24, 8 and 6, 3 and 16, 12 and 4. So since it has more than one factor pair, we are going to say that it is composite. And I'm going to let you write your definition down here, or your answer down here. It says, how do you know? Hopefully you would say something like, it has more than one factor pair. Down here it asks you to study the list of factors, which I would say the easiest way to study it would be to look at these pairs here. and it says, what patterns do you observe? Well, if I were to write it out, like there's a 1 and a 48, a 2 and a 24, 3 and a 16, 4 and 12. Let's see, what else was there? Was there 6 and 8? Okay, I think that's all I can remember from above. So each one of these is a factor pair. 2 goes with 24, 3 goes with 16, 4 goes with 12, I'm running out of room, and 6 goes with 8. So when I look at this, do you see any patterns as you observe these pairs that go together? I don't really want to tell you the pattern. What I'd like you to do is come up with some idea. There is something interesting about maybe the size of the number, like how small this number is and how big this number is. But maybe as you get closer to the middle, you notice something change a little bit. I'm going to let you decide. Make sure you're pausing this video if at ever you feel like you need time to catch up. Or maybe you want to work ahead and then check your work with mine. Totally fine too. We're going to write in the missing missing parts on this number line. Well, as I look at this number line, it kind of looks like you have 3 times 7, 3 times something, 3 times 9, 3 times something, 3 times 11, 3 times something else. Looks like we're counting by threes. And if we have 7 something, 9 something, 11 something, we might be able to guess that the other number is going up by 1. But let's see. Let's start with the first one, 3 times 7. If you want to pause and figure that out, please do. 3 times 7 is 21. And since we're counting by threes, we're basically adding 3 more, right? So if I add 3 up top, I'm going to add 1. Ooh, I said that backwards. If we're adding 3 down here with our answers, we're going to be adding 1 to our factors, okay? So that 7 becomes 3 times 8, okay? Then if you think, well, this 8 increases by 1, well, then that means this has to increase by 3. 24 plus 3, 27. And this looks like it increases by 3 on the bottom, so we know up top that needs to increase by 1. And it looks like this increases by 1, so we know that this has to increase by 3. It's a nice pattern. And if I look down here, this increases by what? And so this has to increase by 1. Find those patterns, but also be thorough. If they threw in a random number here, maybe they changed this. Just pretend with me for a second that this was 39, right? Well, then that would have changed by adding 6. Well, if you were to add 6, you would have had to add 2 up top. So that's just something to be aware of. We might guess that it's going to be the same. No need to guess. Use your eyes, use your powers of observation, get into the details and make sure they're not trying to trick you. Looks like tea light candles are being packaged 6 to a box, and we're going to fill in the table based on number of boxes. And this does look like it might go up by 1 at a time, but let's make sure. So 4 in 4 boxes, there are 24. We said there are 6 in each box, so 4 times 6 is 24. That makes perfect sense. Now, let's track this. It looks like this goes up by 6. There's 6 in a box, so we are going to add 1 here, so we have 5. Looks like we add 1 box. We said that there are 6 in a box. We add 6 more. We add another box. Once again, there's 6 in a box. We add 6 more. Now kind of have to think of this backwards. 42 to 48, it looks like they added 6. So up top, I have to add another box. They added another box. Like we said, there are 6 in a box. So that would be 54. And then to get from 54 to 60, you need to add 6 more. So we are going to add another box. Okay, so that one works really well. They didn't put any tricky numbers there, but if they did, we could have caught it by being very methodical as we go through it. Jane has 7 tea light candles. Aisha has 5 times more candles than Jane. How many candles does Aisha have? Well, I do like that they clearly said 5 times more. So if Jane had 7, whoops, that's not what I meant to do. If Jane has 7 and Aisha has 5 times as many, there's our equation right there. If you know that math fact, great. If not, you could do a little calculation to figure it out. Make sure you label your units in candles. I'm going to let you work on that one. Always pause the video if you need time to work. Theo has 50 tea light candles. Madeline has half as many candles as Theo. How many candles does Madeline have? Well, since Madeline doesn't have like times as many, like more, we have half as many. That's fewer tea light candles. Well, it looks like we're going to be dividing. And whenever you see the word half, you know that you're dividing by 2. So I could take the 50 tea lights and divide it by 2 to get my answer. If you wanted to flip that into a multiplication problem, you could put the larger number on the other side of the equal sign, and you could say 2 times what equals 50. Regardless, you have to have the same answer, okay? If you cut 50 in half, you'll have the same answer as if you say 2 times what is 50. And I'm going to let you solve that. If you have any questions, make sure you ask a math wizard that you trust. Could be a friend, a family member, but don't forget your teachers love to answer questions about math. Check you later.